Assalamu alaikum. Welcome to another class. Today we will discuss electrical energy. Have you ever thought about how electric bulbs light up, how your mobile phone gets charged, or how an electric iron heats up? The answer lies in two amazing physics concepts. Number one, electrical energy, and number two is Joule's law of heating. So let's dive into it. Electrical energy. So it is the energy that comes from the movement of electric charges, means electrons in a conductor. In simple words, whenever an electric current flows through a device, it carries energy that helps it work, like lighting up a bulb or running a fan. One of the interesting examples of electrical energy is ceiling fan. The electrical energy is converted into mechanical energy to spin the fan blades and keep you cool. Another one is light bulbs. When you turn on a light switch, electrical energy flows into the bulb and converts it into light and heat energy. Number 3 is electric cars. These cars use batteries filled with electrical energy, which powers the motor to move the car. Now, what is Joule's law of heating? Joule's law of heating states that the heat produced in an electrical circuit is directly proportional to the square of the current, the resistance of the conductor, and the time for which the current flows. So mathematically, W is equals to I square RT, where W is the heat energy that will be in joules, I is the electric current that is in amperes, and R is the resistance of the conductor that is in ohms, and T is the time for which current flows in seconds. Let's derive this formula. As we know that W means work done is the product of QV, so we'll substitute the value of Q from the formula for current, that is I is equals to Q by T. From this we can conclude that Q is equals to IT and substitute this value in the equation of work done. And the result will be W is equals to V into I into T, where V is equals to IR. So we'll substitute this value from Ohm's law into the equation of work done, and the final result will be W is equals to I square RT. So this equation is called Joule's law. An interesting example of Joule's law is electric iron. The coil inside the iron heats up due to resistance, allowing you to press clothes. Number 2, fuses. When too much current flows through a fuse, it heats up and melts, thereby breaking the circuit to prevent electrical fires. Number 3 is electric heater. The metal coil inside the heater gets hot because of the high resistance, converting electrical energy into heat to warm up your room. So every time you charge your phone or use an electric heater, remember you are using electrical energy, and Joule's law is silently doing its job. Now let's define electric power. Electric power is the rate at which electrical energy is consumed or produced by an electrical device. In simple words, it tells us how fast an electrical device uses energy. The formula for electric power is P is equals to VI, where P is the power in watts, V is the voltage in volts, and I is the current in amperes. Units of power. The SI unit of power is the watt. So 1 kilowatt is equals to 1000 watts. 1 megawatt is equals to 10 raised to power 6 watts. An example of electric power includes electric car vs bicycle. An electric car uses a lot of power, for example 50,000 watts or more, because it needs to move a heavy vehicle fast. On the other hand, an electric bicycle might only use 250 watts because it's lighter and doesn't need as much energy to move. Have you ever seen your electricity bill and wondered what kilowatt hour means? What if I told you it's not just a unit but the key to understanding how much energy your home uses? Today, we'll break down the concept of the kilowatt hour in the simplest way possible. So let's define it. Kilowatt hour is a unit of energy that represents the amount of electrical energy consumed when a device with a power of 1 kilowatt operates for 1 hour. In simple words, 1 kilowatt hour is equals to 1000 watts of power used for 1 hour. So the formula to calculate energy in kilowatt hour is energy is equals to power multiplied with time, where power in kilowatt is the rate at which energy is used, means 1 kilowatt is equals to 1000 watts, and time in hours is the duration for which the device runs. A real-life application of kilowatt hour is electricity bill. When your electricity bill says you've consumed 300 units, it means you consume 300 kilowatt hour of energy that month. That's the same as using a 1 kilowatt heater for 300 hours. Have you ever wondered why your phone charger works differently from the electricity that powers your home appliances? That's because of two types of electric current. The one is direct current and the other one is alternating current. Now what is direct current? It is the type of electric current that flows in one direction only. In simple words, direct current flows like water in a straight pipe, always in the same direction without changing. An interesting example of direct current is solar panels. Solar panels produce direct current as sunlight creates electrons that move in a single direction. Power banks. The energy stored in power banks is direct current, which is why they can charge your devices directly. Now, what is alternating current? It is the type of electric current that changes its direction periodically. In simple words, alternating current flows back and forth like the tides in the ocean, sometimes moving forward, sometimes backward. An interesting example of alternating current is microwaves and washing machines. These devices use alternating current because it works efficiently with large motors. Another example of the alternating current is home appliances. The electricity in your home sockets is also alternating current. It powers fans, refrigerators, air conditioners, and TVs. Now let's talk about the difference between direct current and alternating current. As we know that direct current flows in one direction, whereas alternating current changes direction periodically. The sources for direct current are batteries, solar panels, power banks, whereas the sources for alternating current are power plants, home sockets, and transformers. The frequency for direct current is 0 Hz, whereas the frequency for alternating current is 50 Hz in Pakistan. Direct current is not suitable for long distances, whereas alternating current is ideal for long distance transmission. Did you know your phone charger converts AC from the wall socket into DC because your phone's battery can only store DC, that is direct current? That little charger is a mini converter. So the next time you plug in your charger or turn on a fan, you know whether you are using direct current or alternating current. If this helped you understand the difference, don't forget to like, subscribe, and hit the bell icon for more quick physics videos and lessons. See you in the next video.